In this video, we're going to have a look at our next lesson on trig graphs and the impact on the period of the graph upon what the graph looks like. We're going to start off just by drawing our two normal functions of sine and cosine. So the sine graph starts at 0, it'll go up to 1 and down to -1. Okay, so it goes up to 1, down to -1, 0. The maximum happens at 90, the maximum of 1 happens at 90. There's a root at 180. The minimum happens at 270. And the full revolution of sine x happens at 360 degrees. So that's y equals sine x. And if we have a look at cos x over here, cos is the one that looks a bit like the valley, something like that. Full revolution of cos takes place in 360 degrees. It starts at 1, goes down to -1. We've got a root at 90 degrees. The minimum value of -1, I should probably write that a wee bit higher up. The minimum value of -1 is here, and that happens when it's 180 degrees. And we've got another root here at 270 degrees. And this is y equals cos x. When we talk about the period of these functions, it means how long does it take for a full revolution to complete. So here, this is what a full revolution of sine x looks like, and we can see that the period of this is 360 degrees. The period of cosine is 360 degrees. And in the last lesson, we saw the impact of drawing things such as 5 sine x would have to the function. It didn't affect the period, but it affected the amplitude. For example, this would go up to 5 and down to -5. Okay, if we had y equals 3 cos x, it would go up to 3 and down to -3. The amplitude would be 3, however the period remains unchanged. We're going to have a look now though at what happens when we alter the period of the function. So here we want to sketch the graph of y equals sine 2x. You'll hopefully notice here that we've got a 2 directly in front of the x. This is different from y equals 2 sine x. When we see that, we know it goes up to 2 and down to -2. But we don't have that. We've got sine 2x. What that means is that there are 2 revolutions of the graph in 360 degrees. Okay, so I'm going to draw my sine graph. But then I need to draw another one, because this value here tells me that there are 2 revolutions in 360 degrees. There's not a number in front of the sine, so it's going to go up to 1 and down to -1. And we now need just to put in the important points. So this point here would be 0. The halfway point in this case would be here, which is 180. This point here would be 90. 270, just finding all the halfway points. Then the maximum of 1 happens at 45. And it also happens here as well, and that's at 225. The minimum occurs at 315 and 135. Just need to bring that up a little bit. So this is the graph of y equals sine 2x. The period of this function, I'll rewrite that. The period of sine 2x is, well, how long does it take for one revolution to finish? Well, one revolution finishes after 180 degrees. So the period of sine 2x is 180 degrees. Every 180 degrees we get a new revolution of sine x. You can see here. 180, then we start again. 180, we start again, and so on. Okay. Our next example, we want to sketch the graph of y equals cos 3x. Not 3 cos x, cos 3x. Okay, that means we're going to have 3 revolutions of our cos graph. This will be quite hard to draw, I think. It helps if I've not got my highlighter on. There we go. Okay, so we're going to have 1, 2, 3 revolutions in 360 degrees. The amplitude is 1, so it starts at 1 and goes down to -1. And then we can mark on the important points. So here's 0. So I've got 3 revolutions in 120. 1, 2, 3. That means the first revolution would need to have finished at 120 degrees. Don't know if I said that properly there. We've got 3 revolutions in 360. So the first revolution would stop at 120. The second would stop at the next 120 degrees, so that's 240, and then 360. We can mark on some more important points, so just keep finding the halfway point. So there's 60. So the minimum of -1 happens at 60. We've got a root at 30, a root at 90, we've got a root at 150, we've got another minimum at 180, a root at 210, we've got a maximum at 240, a root at 270, a minimum at 300, and a root at 330. So we can see how these are all tying in together here. Okay, so the period of cos 3x is, well, how long does it take for one revolution to finish? Well, it takes 120 degrees for one revolution to finish. So the period of this function is 120 degrees. Okay, so we need to be able to draw them as well as identify them. So let's have a look here. There can be instances as well where the amplitude is not just 1. In those previous examples, it went up to 1 and went down to -1, but that's not always the case. Let's have a look at this example here. We've got y equals. Do you notice that it goes up to 10 and down to -10? So it's going to be 10. Then is this a sine or a cosine? Well, it's like a valley, so that's a cos. So it's going to be 10 cos. And how many revolutions are there? There are 1, 2 revolutions in 360. So this is the graph of 10 cos 2x. Let's have a look at this one on the right. It's going up to 5 and down to -5. So this is going to be y equals 5 sine. How many revolutions are there in 360? 1, 2, there are 3 revolutions. So this is the graph of 5 sine 3x degrees. Okay. Sometimes there can be like a little twist. If we have a look and we want to identify this graph here, well, we can see that it goes up to 4 and down to -4, so that's going to be 4. It's clearly a sine graph. But then we need to ask ourselves the question, what value should go here? Because this value tells us how many revolutions there are in 360. And I've only got 120. I know that one revolution finishes after 120 degrees. Therefore, in the next 120 degrees, 240, I would have 2 revolutions. And then in another 120 degrees, I would have my third revolution. So therefore, it would be 4 sine 3x. And here the period is 120 degrees. And the amplitude is 4, because it goes up to 4 and down to -4. Hopefully that was helpful. You can now have a go at identifying and drawing graphs with different periods and amplitudes. Thank you.